Well, hello everybody. This is SQL Dan coming at you tonight with another solution to a problem from the Snowflake forums. And even if this is not your question, I hope that I can share some information and some tricks that might be useful for you as you do your own work sometime in the future. The question that I'm looking at tonight comes from H. Doofenshmirtz, and hopefully that's how you say it. Anyway, uh, the question, the questioner has an issue with the recursive CTE, CTE common table expression, and there's some code here. But essentially, what the user is attempting to do is to generate a list of dates that occur between two other dates. So if I go back and look at the code that the user posted in there, um, we'll see that there's a date from and a date to, and the idea is to use the recursive function to fill in all the dates in between, so it can be done like that. Now the poster didn't provide any actual sample data, just the sample code. So I've created some sample data here. I've created just 4 records, and I've put them into a temp table that I called data, which is exactly what the poster had it named in his code as well. Okay, so the issue that he had with his code was that he was doing this with a recursive CTE, and he was trying to get around a problem about max recursion, a number of recursions, and the post was originally about how to solve that problem and how to change that. And unfortunately, I believe the answer directly to the question is that there's not a way that he can change the max recursion parameter, at least not at a level of a session. But that's okay because this problem can actually be solved much more easily than by recursion. It can really be solved with something that goes all the way back to the beginning of databases, which is a Cartesian product. So that's what I'd like to show you now is my Cartesian product solution to the problem that was posted. Oh, and by the way, if you'd like to go read the problem yourself, I do have the link to that Snowflake forum posting in the description of this video. So you can go down there and take a look at that and then go read it yourself if you'd like to investigate that further and see the details of it. But anyway, so here's the data that I created. Okay, and I'll just query it really quick just to show you. Oops, goodness. There's just 4 records. There's an ID, there's a date, and a date end. And I was actually surprised that date wasn't a reserved word that caused issues. But I chose these field names and table names because this is exactly the field name and table names that he used in his post. So I thought, all right, we'll just try to make it as close to it as possible. Anyway, so I just created 4 records, and each one of them contains, I guess there's 5 records here, some variants of a date range. And again, the idea is that we're going to want to be able to create records for each ID with all of the dates in between filled in. And as I've mentioned, we're going to do that with a Cartesian product. And the Cartesian product is simply going to be a list of all of the possible dates. Now, again, I don't know his data, so I don't know exactly what his date ranges are. So I just decided to do 100 years worth of dates. So you might think, wow, that's a lot. Yeah, it's 36,000 of them. And if you try to do 36,000 recursions, Snowflake definitely would not let you get away with that. But Snowflake has a generator function that will allow us to do this pretty easily. And in fact, the generator function is tuned to do just exactly what we're going to do here. So looking at line 78, what I have here, okay, is, well, we'll start with 79, the from clause and from table, and then generator, and then row count. So I basically tell it how many rows I would like for it to generate into a table. It's that simple. And then I guess I have to have something in the select clause as well. So in this case, I'm going to use the row number function. And the row number function simply numbers rows in an output. It's an analytic function. Okay, it's one of the ranking functions. But the good thing about the row number function is that it only returns each number once. There's no duplicates, and there's also no gaps. So it'll just start numbering from 1 and go forward. And in this case, since I requested 36,525 rows, if I were actually to scroll all the way to the bottom, you'll have to take my word for it, but the last ID down here would be 36,525. Or if you don't want to take my word for it, you can easily type this up in your Snowflake as well, and you can test that out yourself. Okay, so I'm halfway there. I have a function that generates 36,525 rows. And so the next thing I do, I mentioned to you that I'd wanted to create 100 years worth of data. And so I randomly picked January 1st of 1950. Now there's no special magic about that date. I was just trying to pick something that goes far enough back that I imagine that whatever data he has is going to fit into it. And even going 100 years forward, whatever data he has is still going to fit into it. If that date range doesn't work, it's easy enough to adjust either by changing the start date or by changing the row number here, right? And so I'm just basically taking the row numbers and I'm adding it to January 1st of 1950. And so since actually row number is not indexed at 0, the very first row would be January 2nd of 1950, and then it would go forward from there. So let's see how that looks. We'll just select here from, I have a CTE, we'll just say select from generate dates. And when I do that, we'll see now, what happened here? Let's try that again. All right, there we go. As I mentioned, the first one is going to be January 2nd because I added 1 to January 1st. But anyway, I have my date range, which is going to go all the way to the year 2049. Actually, I guess it'll go to 2050 on January 1st to kind of close out the entire 100 years. But I have, one row for every single date in a 100-year period. And now I am ready to use that and cross-join it to the data I have. And again, the data set that I'm using is this sample set that I have here. And we have these records right here. And so I have my with clause, the CTE, and then I'm selecting from the data table the ID, the date, which is the beginning date, and the date end. Okay, and then I'm selecting the my date field, and the my date field is what's coming from the common table expression. Okay, and then there's a Cartesian join right here. So every record in the generate data table is being matched up with every record in the data table. So there's a heck of a lot of records right now, but I limit it by saying where my date, or in other words, where this date that's somewhere in the 100-year range is between the date beginning and the date end of the other table. And that effectively will get me to exactly the records that I wanted it to return. So let's run this, and goodness gracious. Doing things live, never know what's going to happen. There we go. So we can see it started with the first one, ID, and it's picking all the records from July 4 of 1999 up until 3/17 of 2021, and it just starts. And, it would take a while to go through 4 years worth of them, but I'm sure that they're all there. In fact, why don't we load these into a temporary table really quick. Create temp table test data, data as, And let's just take all of these results and load them in there, because then I can run some queries on it. Oh, that's right, because I tested this before I came online here. Anyway, so all of these are already in the test table. How about that? All right, and so select count from test data. And there's 11,000 records there between those 5 IDs. Now, I don't know if that's good or not, but we can also group them by the ID field and see how many we have for each one, and then we'll go back and look at the original data. And that should give me a good sense as to how effective this was. There we go. So let's pull this up a little bit here. Come on. There we go. And I'm just going to take a peek at the original data that I seeded in. Okay, ID number 1 went from January 1st of this year through June 30th. It's about a half a year. And we see ID 1 has 182 records. ID 2, as I mentioned, has about 4 years worth of data. No, that's this one. 1999 through 2021. And we see 7,900 records. That sounds to me to be, oh, because it's not 4 years, that is 22 years, isn't it? Yeah, okay. 22 years, so I would say that that's right also. The next one goes from 2014 in December up until May 5th. That's ID 3, 127 days. The next one, ID 45 and 46, are both the same length, and they both go from January 20th to January 20th. So I'm going to say that this is a success. And so even with the glitches that we've had here in this one, which I apologize for, I think that we've been able to show that we don't need to do this recursively, that a Cartesian product is fine. And I hope my explanation made sense. And again, I apologize for all the beeping and stuff that went on in the middle of this. But that's it for now. I appreciate you listening. If you like this explanation, I hope you'll like the video. And I hope that you'll follow me, because I have lots more Snowflake SQL videos that I'm working on producing. And we'll try to increase our production values as we go along. Have a great evening. Good night.